The limit of a sequence is pretty close to the limit of a function. Where if you plug in, or as your value of n gets bigger and bigger and bigger, you converge or diverge to one limit point. So it's not a big change from a function. So let's say, for example, let me put my remember up there from last class. A sequence said to converge if, I guess you can say they, since it's more than one term, since they are approaching a limiting value. Okay. So in other words, let's say if you have all of your n values, I might as well say this is n, and as n approaches infinity, let's say this is your a1, this is your a2, this is your a3, let's say it's a4, a5, a6, a7, a8, 9, 10, 11, 12, so forth, so on and so on. It can even oscillate as long as it gets closer and closer to a limit value. So let's say this is your limit value here. So you can bounce up and down past it as long as it's converging towards it. Okay, so it's kind of like if you have the limit of, let me think of a good one, negative, let's say for example, negative 1 to the nth power over n. Okay. So as n approaches infinity, you have the limit of negative 1 over n divided by n as n approaches infinity. Okay. So there, if you plug in n equals 1, you'll end up with negative 1, and you'll have positive 1/2, and negative 1/3, positive 1/4. It's bouncing back and forth, but it's getting closer and closer to 0. So even though it's oscillating towards a point. It's not like sine, where sine just bounces between negative 1 and 1 forever. This is actually oscillating, but it's getting closer and closer to a limit value. Does that make sense? Okay. Okay, so as n approaches infinity, the limit oscillates but approaches 0. All right, so any questions on that one? All right. Oh, and just a quick reminder, if the limit doesn't exist, it diverges. Sequence diverges. Oh, probably leave it out in case someone else needs to sign in. Thank you. So let's say, for example, let's say for, instead of A sub n, bless you, sometimes they may say the sequence B sub n or C sub n or any variable at all. Same thing, basically. Okay, equals n over 1 minus 2 times n. I want to find the limit. All right, so we have the limit of n over 1 minus 2n as n approaches infinity. Okay. So if you remember from Calc 1, the limits to infinity, whenever you end up with infinity over infinity, you can do one of two things. You can apply L'Hopital's rule, or you can divide every term by n. Either way, you get the same answer. Okay. So if you did use direct substitution, you'd end up with, you plug that in, you get infinity. If you plug that in, negative 2 times infinity is just negative infinity, which is still an indeterminate form. Okay. So we just apply L'Hopital's rule. Okay, so that would be the limit of the derivative with respect to n of n over the derivative with respect to n of 1 minus 2n as n approaches infinity. Okay, so that would just equal the limit, clean that up a little, as n approaches infinity of 1 over derivative of 1 minus 2n is just negative 2. So you end up with just negative 1/2. Okay. Like I said, another way to do it would just be n over 1 minus 2 times n as n approaches infinity. Divide numerator and denominator by n, or multiply by 1 over n. Okay, so you end up with the limit of n over n divided by 1 over n minus 2n over n. So you end up with the limit of 1 over 1 over n minus 2 as n approaches infinity. So as n approaches infinity, this just becomes 0. 1 over 0 minus 2, which is just negative 1/2. Okay. So there are a couple of ways you can solve them, at least for a lot of them. All right. Any questions on that one? Right. So let's say, for example, we wanted to determine if 7 minus n to the 5th power converges. And if it does, what does it converge to? So if so, find the limit. Okay, so we already know that the limit as n approaches infinity of n is just infinity. Okay. So if we have the limit 7 minus n to the fifth as n approaches infinity, you actually just have here -1 times n as n's getting bigger and bigger and bigger and bigger and bigger. Plus, if you get that negative really big number to the fifth power, it's still just a negative really big number. So in this case, it's going to equal, actually, that's another way, negative infinity. So in other words, this one diverges. All right, any questions on that one? Leave it up there for a few more seconds. All right. Let's say if we have, for example, determine if 5 plus 4 over n to the fifth power converges. And if it does, find the limit.
Is it n to the fifth?
Yes, n to the fifth. All right, so just using our basic limit properties, the limit of 5 plus 4 over n to the fifth power as n approaches infinity, pretty much we can just distribute the limit to both. So the limit as n approaches infinity of 5 plus the limit as n approaches infinity, of 4 over n to the fifth power. Okay. Now from Calc 1, again, you just remember that the limit of any constant over x to the whatever, in this case n, as x approaches infinity is just 0. So this just becomes 5 plus 0, which is 5. So hopefully this kind of looks familiar. All right, any questions? Yes.
So if that was 5 plus 4 in the numerator, would it pretty much be the numerator?
You said if it were...
Well, not the numerator, but like, how would that happen? If it was 5 plus 4 in the numerator?
If it was 5 plus 4 in the numerator?
Yes.
You mean in this one?
Yes.
Oh, if it's any constant at all, it's eventually going to be 0. So even if you had 100,000 up here, if n gets big enough, 100,000 over a billion to the fifth power isn't going to seem like much. So it's still going to get closer to 0. Does that answer your question?
Yeah.
Oh, okay.
I think I was asking if you could put it.
Oh.
It's okay.
Oh, okay. All right. Any other questions? All right.
Okay, I think I got it. Okay, so say there was an n in the end, the numerator is kind of what I meant.
Oh, if you had an n up here and
Yeah.
into the fifth?
Like an n plus 4.
Oh, you mean if you just had n plus 4 here?
Yeah.
Oh, then you'd have 5 plus infinity, then it would just be infinity. Yeah. Oh yeah, if you have really any polynomial here, it can be either positive infinity or negative infinity, depending on your lead term. Yes.
If it were n+4 over like n to the fifth, wouldn't that just split up into two different fractions?
Oh, if it was n+4 over n to the fifth, yes, because your n+4 was that
Yeah,
your question? Oh, that's what you. Oh, okay, okay. Yep. So if you have n+4 over n to the fifth, then that would just become n over n to the fifth plus 4 over n to the fifth.
Okay. And then both of those would go to 0, right?
Yep. Then both of those will go to 0 because you have 1 over n to the fourth. So both of those will go to 0. I misunderstood your question.
No, it was poorly then.
All right. Any other questions on this one? Okay, so this is just an if is of n equals n+4 over n to the fifth. So hopefully no one will think that's part of the question.
So this converges to 5, right?
Yep, this one converges to 5. All right, so really it's the same approach for trig functions or any other type of function. Let's say, for example, if you wanted to determine if e to the 8 plus 8 over n squared converges or diverges. Oh, clean that up a little bit. Okay, so if we get the limit as n approaches infinity, okay, as n gets bigger and bigger and bigger, this just gets closer and closer to 0. So it's actually e to the 8 plus 0 power, which is just e to the 8. So we know that this converges. Whatever e to the 8th power might be. All right, so let's say if we decide to determine if tangent of 5 pi over 4 plus 4 over n to the 7th converges or diverges. Okay. So once again, we're just going to take the limit as n approaches infinity. Of tangent 5 pi over 4 plus 4 over n to the 7th. Okay. So we know as n gets bigger and bigger and bigger, that just gets closer and closer to 0. Okay, so we end up with the limit as n approaches infinity of tangent 5 pi over 4 plus 0. Which is just tangent of 5 pi over 4, which is equal to 1. So any questions? Yes.
Do we look at how to find what value that it converges at?
What do you mean, which value?
Like, say,
Oh.
like, we're looking at it graphically,
Mhm.
do we ever look at, like, how to find where on the graph it converges, like, at a sub whatever?
Well, most of the time you can see, like, with tangent of power 4. Trying to think of the best way to graph that one. Most of them, you can see as it gets bigger, it kind of reaches a ceiling. So I'm trying to think if I'm explaining that the right way. Where, I'm trying to think. Let's say if you have a graph, say your x and your y, and let's say you have various values of n, and it's getting bigger and bigger and bigger. Most of the time, you'll see your limit. It'll just approach it from one direction. Or in some cases, it'll approach it from this direction. Now, if you're looking for an exact limit, if you have an exact limit, it'll be a little different than finding the decimal limit. Because if you're looking at it from like a decimal standpoint, it may be some crazy looking decimal. But just from an exact value, you'll get something that jumps right out at you. I don't know if that answered your question.
I was just asking if you have to find out where it converges. Like,
Only if it asks.
Okay.
Yeah. If it, a lot of times they just say, oh, if it converges, then to what? But
I would say like an X value at which it converges.
oh no, for the most part, no. Only just your limit value.
So how would this work if there's something like a horizontal asymptote or whatnot? In some cases, you know those weird situations where you have a function that has a horizontal asymptote, but at some point needs to cross that horizontal asymptote in order to get to the other side of the symmetric function.
If there's trying to see, I think I know what you're asking. So you're saying if you have your limit, which would be your horizontal asymptote,
Yeah.
but if it's approaching here and at some point would cross
Yeah.
and go up. Well, if it's a horizontal asymptote, it shouldn't cross unless it's like some really odd looking sequence. But if it does, and if it crosses and it continues to go up, then it wouldn't converge. So it's only if it never crosses that point as it gets bigger.
Okay, just wondering because I've seen those weird situations where you have like two asymptotes
Mhm.
and one of them's stronger than the other, so it just pushes right through, like a diagonal versus a vertical asymptote. I'd have to probably.
I'd have to see a question like that. I don't think you run across anything like that here, but
Okay.
I'm pretty sure they probably exist out there somewhere, just not here. All right, so let's say you go over the properties of the limits of a sequence, which really doesn't differ too much than the limit properties that you've already been used to. Good. What if we let the limit of some function a, that's some sequence, as n approaches infinity equal L, and the limit of some other sequence as n approaches infinity equal uppercase K. You can make it L and K, A and B, capital A and B, whichever one you want. Okay, so the limit of the first sequence plus or minus the second sequence as n approaches infinity, which is what we already did before, kind of distribute the limit to both. Which is just your L plus or minus K. Okay. Second, if you have the limit as n approaches infinity of some constant c times your sequence. Okay. So if you have a sequence and they're all just all of them have 2 in the numerator, it doesn't go up or down or anything, it just has 2, you could factor out that 2. So that constant times the limit of the A sequence as n approaches infinity, which is just equal to the constant times L, where C is a real number. Okay. Same thing as if you have a product of 2 sequences, AN times BN, as n approaches infinity. It's just going to equal the product of their limits. The same thing if you had the quotient of 2 sequences. As n approaches infinity, it's just going to equal the limit of A over the limit of B. And of course, that's assuming that your sequence doesn't equal 0 and the limit of that sequence doesn't equal 0. All right, so let's say, for example, bless you. Determine if, I'm trying to think, do I have enough room? I'll start on a new page. Don't want to run out of room. So determine if the sequence A sub n equals n squared over 2 to the n minus 1 converges or diverges. Okay, so whenever they want to know convergence, you pretty much just want to look at the limit as n approaches infinity. So the limit of n squared over 2 to the n minus 1 as n approaches infinity, if you look at it this way, if you plug in infinity squared, you just get infinity. So as it gets bigger, your n squared will just get bigger. And 2 to the power of infinity, it would just keep getting bigger as your infinity gets bigger. Okay. So you actually have infinity over infinity, which means you can use L'Hopital's rule because this is your indeterminate form.